when you put the spring here, here you have the spring, and you have a mass. So this is the spring, and this is a mass. So when I put the mass, you can see that this will go 10 centimeters. It reached a new equilibrium position. If I want to find K, how can I find it? It went down 10 centimeters. How can I find K? mg over x. This is the experiment I was talking about. So you let to go down a certain distance. This is the 10 centimeters they talk about. With those 10 centimeters, the mass, so you can find what will be K. We have K. So if I ask, find K, which they didn't give there, if I said, find K, so a body of mass 5 kilograms is suspended by a spring which stretch 10 centimeters. D, 10 centimeters. This is to go to the equilibrium point. It is then displaced downward an additional 5 centimeters. And it will go now from this distance that went down, 5 up and 5 down. Its position as a function of time is approximately given by what equation? Which one you think? The last. Why?
Because it's moving 5 centimeters from the new point.
And that point is called amplitude. Because the amplitude is 0.05 centimeters. So you need to know that the equation, that the only one that has A in front of cosine is 0.05. The other one has 0.10. So that is the equation. Good. What will be omega? I can ask A, find K. So how can we find K? mg equal kx or kd, just to not confuse with the x of extension of the spring, kd. So K is equal to mg over k over t, sorry, which have to be meter. You have to divide by 100. Good. Next question, B. Find the amplitude. How much?
0.05.
C. Find omega. Look at the question and find omega. How much? You have the square root of k over n. If you look at the equation, immediately, what have to be? 9.9. 9.9 radian per second. 9.9 radian per second. Any question? Yes, from simple taking a look to the equation, you need to know, or you need to recognize that omega is 9.9. What will be the period? T. How is omega and the period related? Omega is 2 pi over what? Omega, which is the angular speed, is the whole angle, which is 2 pi, divided by how much? By the time. So what will be T? 2 pi over omega. Since we have 9.9, which is the same, that if you have K and M, you can just get it also. The difference is that this is the reciprocal. This is 2 pi over omega. So since we have omega, we can say 2 pi over omega or which is the same, 2 pi the square root of m over k. It doesn't matter, but we have already omega. Find the velocity at any time. Find the velocity at any time. What do you do? What is given? What is the function given?
Position.
Position.
Derivative.
How can you find the velocity? You find the derivative. Remember that we are working with oscillatory behavior. So we have the position, you need to find the velocity, you just get the derivative. Negative 0.05, positive, the velocity, sorry. The velocity will be negative because it's the cosine, 0.05 times 9.9 times sine 9.9t. This is the velocity at any time. What about if I ask for the velocity at 2 seconds? You plug it in. Find the maximum velocity. What will be the absolute value or the maximum speed? Maximum speed.
9.9 times 105.
That will be the maximum speed. Find the acceleration. Find the acceleration at any time. What do we do? Derivative of the velocity, which will be the negative 9.9 squared times 0.05 times cosine 9.9t. Find the maximum acceleration. So, the last two questions that I covered, one from energy perspective, one from oscillatory perspective, is the question number 1 in the final exam. So that will be the question number 1. In the block spring system, free response. So the block spring system, I just can give either an equation where I can ask everything about energy perspective and about oscillatory behavior. Any question? Today, I think that is enough.